I would like to introduce Dr. Lauren Lieb and Dr. Brian Tarpley, who will describe the future of the Advanced Research Consortium, or ARC.
All right, so as Laura said, I'm Lauren Liebe. I'm the project manager for ARC. And today I'm going to talk a little bit about what that looks like and also the potential for ARC to grow. All right, so as Laura said, we have come a very long way since NINES was founded in 2005 as the first project in what would eventually become ARC. And here you can see a timeline for sort of what those projects have looked like. All of this history means that we have learned what kinds of structures are necessary for managing the resources from many different projects, each of which has its own particular goals and needs. However, this long history also means that we have a lot of legacy systems that are in need of updating. Today, I will be talking about all of the projects and the data that make up ARC, and then I'll close by discussing our next steps in the future of the project. Okay, so ARC is quite large. It has 5 active nodes, as Laura talked about, with several more in active development that will be joining us as official nodes, hopefully sometime in the next year or two. Currently, we house over 300 federated projects across all of these nodes, which makes for now probably closer to 3 million points of data. So we have a lot of information that we are covering, and it is constantly expanding. For example, just within the last couple of weeks, I've added the W.E. Du Bois papers collection in Zero, which added 1,000 new artifacts to ARC's catalog. And each one of these artifacts is backed by a wealth of metadata, which Laura described fairly in depth. But I want to highlight that the metadata standards are the same across all of the projects and nodes, which means that all of the data across this entire body of scholarship is really interoperable. You can search sort of across the different nodes all at once. Variations between projects, of course, do complicate this somewhat, and I'm happy to talk about sort of like the discrepancies between metadata with different projects in the Q&A. But all of this metadata is right now submitted as RDF files formatted in XML. But we do use the pre-existing schema from Dublin Core and the Library of Congress for later terms. When each artifact is submitted to ARC, we ingest it into that database, and then we are in the process of translating that over into our new back-end system, corpora, which Brian will be discussing in depth in a little bit. In the future, we hope to simplify the entire process of this metadata ingestion by allowing project managers to input their data directly into corpora, sort of skipping the XML step in between, either through uploading an RDF file that's currently existing or through using the more friendly graphical interface that corpora offers. And then Laura touched on this briefly, so I'll just sort of briefly talk about this. We also have a customized set of taxonomies for disciplines, genres, and formats. And these are tailored to the specific needs of digital humanities projects and the types of objects that they're most likely going to be working with. These taxonomies provide scaffolding for thinking about the works in question, both for the project developers and for later users. These taxonomies are really designed for the end user. They're meant to be very human searchable. They're meant to sort of mimic the way that we as humanists tend to think about these projects as we're working with them, as we're exploring them, as we're searching for them. Right now, we are teamed up with the Lynx project, and we are in the process of bringing all of this metadata in line with linked open data principles. What that looks like in the initial stages is adding URIs to every individual entity and work that we aggregate within ARC. and human vetting them, because as I'm sure we all know, when you try to create a script that goes out to VIAF or goes out to Wikidata to locate a particular entity or a particular work, we can only do so much. And our current system for searching these databases is very good, but it does occasionally have errors due to either the way the metadata is originally formatted, due to gaps in VIAF. And then so the next stage of the project will be to go in and find what is missing and mint our own URIs for people, works, projects that do not currently have that data out somewhere in the web. All of this work means that ARC's projects are increasingly becoming interconnected, not just with one another, but with sort of this broader sphere of knowledge that the Linked Open Data Project offers us. All right, so I talked a little bit about sort of the history of ARC. And what this means is that right now, our front end for the user and the back end, but Brian will be discussing that in a minute, is a little bit outdated looking. This is what the current front end of Nines looks like. And it's perfectly serviceable, but 15 years on, we can definitely do better. The Colex infrastructure can be a little bit difficult for the ways that we currently think about how best to navigate between different projects and different connections between projects. It's based on a Ruby on Rails backend, which, again, a little bit outdated, and we also don't have somebody actively on our staff who does that kind of work. And then also right now it runs through a limited WordPress integration where parts of the front end talk to WordPress, but others require somebody to actually go into the database and manipulate the information. So it could be more user-friendly. That's what I'm going to spend the last part of my presentation discussing, is where do we go next? What is the future of ARC? So within the next few years, we will be rebuilding both the user interface and the backend to make use of current technologies that also line up with the best practices for humanities scholarship. In this, our main goals are making the projects more accessible, making the interface more user-friendly for both scholars and project developers, so making all of this information easier to find, but also easier for people who are just getting their digital humanities projects off the ground to sort of integrate with. And then also making all of this data more interoperable across the individual projects and nodes through the linked open data process. On the front end, this means that we're going to be having much more user-friendly, customizable WordPress instances, leveraging the new Gutenberg blocks. On the back end, Brian will be discussing our data management suite, Corpora. So the first steps for this, we will be redesigning modnets and nines, so two of our nodes. And this will be beginning in the fall of 2021. Over the next couple of years, we will be launching our new nodes, Muso, Music Scholarship Online, Near, Quirk, and DigiDS, which Laura all talked about. And then after we've gotten those up and running, we're going to be looking into developing new period and theme specific nodes. So trying to work with scholars in fields that either are currently overlooked in ARC, places where we have gaps, or new and emerging fields of scholarship, so that we can help sort of aggregate all of that data as it is coming into being. I'm really excited to see where ARC is going in the next couple of years, and I look forward to answering any questions you have about our plans or about our current metadata structures. All right, and with that, I am going to go ahead and pass things over to Brian.
All right, thank you, Lauren. I'm going to start by pasting my Google slide deck into the chat in case anyone wants to follow along. And let me go ahead and share my screen. Okay. Well, good morning, everyone. My name is Brian Tarpley. I'm the lead software developer at the Center of Digital Humanities Research here at Texas A&M, as well as the Associate Director of Technology for the Advanced Research Consortium. I'm here to talk about how we're using a tool called Corpora to ingest, wrangle, and improve ARC's large data set of bibliographic metadata, ultimately with the goal of replacing ARC's legacy infrastructure altogether. Corpora is a web application that our center has created over the course of the past 5 years in order to serve the needs of a variety of DH projects. And thanks to recent grant funding from the Linked Infrastructure for Network Cultural Scholarship, or Lynx project that was mentioned earlier, we'll be writing up robust documentation and properly open sourcing Corpora within the next year or so to make it more widely available. So we're excited to share it with you today as a kind of preview of coming attractions. As Laura mentioned, ARC is an aggregator of metadata for scholarly digital artifacts. In terms of organizational hierarchy, there is a central ARC office here at Texas A&M. But the reason we refer to ARC as a consortium is because it's comprised of various scholarly communities or nodes. So far, ARC has aggregated metadata for roughly 2 million digital artifacts and counting. And at the ARC office, we receive this metadata curated by a project manager for one of the 5 nodes in the form of RDF XML files. So while there are several reasons why we want to replace ARC's legacy infrastructure with Corpora, and I'll get to those shortly, the most exigent reason has to do with our participation in the Lynx project. ARC's chief role in the project is as a data contributor. And our broad goals are first to automatically ascribe an authoritative URI to each of the nearly 600,000 named entities in our catalog and human vet them when possible. And the second goal is to convert all of those 2 million bibliographic records into linked open data triples that adhere to the Lynx ontology and can be ingested into their triple store. For reasons that will become clear, we could not rely on our current infrastructure to accomplish these goals, at least not in any kind of timely fashion. So to give you an idea about that infrastructure, or current legacy infrastructure, as I said, all of our metadata lives in XML files. These files are stored in a Git repository associated with the archive they belong to. So we, for instance, aggregate metadata from the Walters Museum. There is a Walters Git repository containing all these XML files with their metadata. When we're ready to ingest metadata from an archive into our catalog, we pull down that archive's Git repo, feed those files into the ARC indexer, which reads and parses the XML, and finally stores it in a Solr index, which, as Laura mentioned, allows us to search, sort, facet, etc. So while the current ARC infrastructure makes it easy to take all the metadata belonging to an archive and index it at once, it becomes frustratingly difficult to make a small change to a single record. To do this, we have to find the Git repository belonging to that archive, clone it, search through all the files to locate the one containing our record, modify that XML directly, commit the change to the repo, and then fire off the indexing task again, which is a lot of work just to change one record. Similarly, should we make a large structural change to our taxonomy of genres, types, disciplines, etc., changing those values in our metadata is a massive undertaking. We have to clone every repo, write a script to check every file for old values, change them to new values, commit, push, and reindex. This amounts to changing over 100 gigabytes of XML data. We also have to go into the source code of the ARC indexer, which was originally written in Java, and adjust the logic that tries to restrict values according to our taxonomy. Our last attempt to make such a structural change was about 5 years ago, and it was such a hassle that we began planning a migration away from what we now refer to as our legacy ARC infrastructure. We've also found that while our Solr index is fantastic at full text searching and faceting and aggregating our 2 million records, it becomes impossible to do other kinds of querying and analyzing. We once attempted, for instance, to index the entirety of the ESTC with the goal of keeping track of not only published books, but also their holdings across the libraries in the world. And while our metadata schema could describe this situation, our Solr index fell on its face when trying to query for records hierarchically. A single query ate something like 17 gigabytes of RAM and then finally timed out. As Brian Geiger's efforts with the ESTC21 project eventually showed, it is certainly possible to modify the code base for the ARC catalog and the schema for the Solr index to support hierarchical queries more efficiently. Nonetheless, we wanted an infrastructure that was a lot more flexible in terms of the kinds of questions we can ask of our data without having to make drastic changes to our code base every time we come up with a new question. Finally, our legacy infrastructure was mostly coded in Java and Ruby, and while there's nothing wrong with those languages, it means we have to either have staff members that are experts in those languages, which we don't, or that we have to contract out anytime we need to make a significant code change. For these reasons, we decided to migrate ARC to corpora, but it was going to entail such a massive amount of work that we kept putting it off. We finally found the impetus we needed thanks to the Lynx project. As I mentioned, corpora is designed to serve the needs of a variety of DH projects. And in my experience, no two projects are alike in terms of what types of content need to be captured, analyzed, and displayed. Another way to put this is that each project is a little self-referential world unto itself with its own uniquely inflected ontology. So for instance, ARC needs to keep track of federations, types, entities, roles, agents, disciplines, genres, etc. And those things need to be able to reference each other in specific ways. So we refer to corpora as a data set studio. And the reason for this is that it has a built-in content type manager that allows you to create these arbitrary content types to build out your ontology of data according to the unique needs of your project. A content type in corpora is ultimately a set of fields that together form a schema for the object in question. So the schema for a named entity in ARC, for instance, is composed of a name, a type, its external URI, whether it's been verified by a human being, whether it needs attention, what are the notes of the human vetter of the URI, what are the alternate names of this entity, etc. When creating a field for a content type, you can select from various data types, which you can see listed there to the left, and many data types provide their own configuration options, such as the text, large text, and HTML types, which allow you to choose a period-specific list of synonyms for the search engine to use when querying the data stored in those fields. As another example, the cross-reference data type allows you to designate a field as a reference to another piece of content stored in corpora. For every field, you can also choose whether the field should be indexed by the search engine, whether it should have a unique value, whether it should be multi-valued, etc. Once you've built out your schema, it can be exported as a simple JSON file for use in other projects by just clicking the export button in corpora's content type managers. Schemas can also be imported using the same format. So I should also note that once your schema is built, you aren't locked into it once you've got data loaded into your content types. You can add new content types, you can add fields to existing ones at any time, allowing your metadata to evolve along with your project goals. Once a content type has been defined, users are able to create or edit a piece of content using a simple web form where the input controls correspond with the data type for each field. Some of those field types, such as the IIIF image URL field, allow you to make use of special widgets, such as this image viewer that makes use of a IIIF server's ability to serve tiled and zoomable images. And I think I actually have this example pulled up in our live instance of corpora. So you can see here, this is a kind of illustration metadata project. You can kind of keep seeing the image tiled and be able to pan and zoom as you need to in order to kind of fill out the metadata for this image. With large-scale projects like ARC, of course, there are other ways of loading content, which I'll speak about later. Once data has been loaded into the project, corpora allows you to browse and search through your content by content type. Here, for instance, I'm searching through our catalog of digital artifacts for items with the author Susan Brown. This interface allows you to search across various fields and to perform various kinds of searches, including exact search, fuzzy search, wildcard, etc. And this interface also allows you to sort by any field and, of course, page through your results. Upon clicking on one of those results, you're taken to that piece of content's unique URI, which by default shows you an HTML representation of the data. In order to fully support the kinds of analyses and visualizations that scholars in the humanities need to produce, however, simply browsing data in a tabular format is not enough. When visiting a piece of content's HTML representation in corpora, you can click on the Explore tab and see a network visualization of how that content is interconnected with other pieces of content. And actually, I can just pull that up live, hopefully to demonstrate that it is an interactive visualization. And you can kind of see at a glance here that this artifact belongs to the VictBib archive. It is a citation, it's federated with nines. And if you're curious about kind of any of these little pieces of data, you can continue to sort of trace out a line of fascination and sort of, and there are other things you can do with this, but we're limited here with time. Let's see here. You can also explore the interconnections between items in your search results. So you can, for instance, select multiple agents, for instance. Here we've got a whole bunch of agents or entities with the name Susan Brown. So if we wanted to explore and see kind of whether or not maybe those authors are maybe the same person and they need to be merged together, we can kind of quickly visualize these interconnections and sort of make that call. All right. By and large, DH projects are about examining existing cultural artifacts. And while it would be nice to live in a world where the data for every project comes in a nice, neat set of Excel spreadsheets, the reality is that scholars come to us with a wide variety of digital data in disparate formats, whether it be a set of PDFs they want to OCR and annotate, a hard drive full of images they want to create metadata for, a database full of bibliographic metadata stored as MARC records, or as in the case with ARC, a collection of over 300 Git repositories containing RDF XML files. While corpora allows users to upload those source files into their corpus, there's simply no one-size-fits-all approach to then extract that data and save the results as instances of corpora content types. For this reason, most large-scale projects like ARC require that data be ingested programmatically. In order to make the development of that code convenient for developers like myself, corpora comes with a built-in coding environment in the form of an ipython notebook that allows you to create and test your code one step at a time using Python, which has become a kind of lingua franca for academic coding, particularly in the sciences, but increasingly in the humanities as well. One of the things that makes corpora unique as a platform is that the backend is written entirely in Python. Once code has been developed inside that environment, it can be easily converted into a task that any authorized user can run on your corpus. This screenshot, for instance, shows the form you fill out in order to launch the ARC indexing task. Corpora's task queue is asynchronous and parallelized, which means you can queue up thousands of jobs at once, and you can effortlessly kind of scale corpora up to run as many task consumers as you need. Aside from allowing you to define your project schema and load the data in according to that schema, corpora provides several means for you to then present that data to the public. The first of which is a simple out-of-the-box API that spits out a JSON representation of your content. Beyond merely allowing you to get to your data as JSON, Corpora's out-of-the-box API allows you to search, sort, aggregate, and explore the connections between your data. You just manipulate the parameters of your API requests, and you can perform all kinds of different searches on any particular field in your schema. You can also provide the URI for a piece of content and see all the other content that either references it or is referenced by that content. Indeed, the front end for Corpora completely relies on JavaScript calls to these API endpoints to present the data. Ultimately, what makes the API so flexible in terms of how you can query your data is that every piece of content in Corpora lives in 3 types of database at once. While technically any one of these databases, or even a relational database like MySQL, could provide much of this functionality on its own. By leaning on MongoDB for quick document retrieval, Elasticsearch for searching, sorting, and aggregating, and Neo4j for exploring the interconnectedness of data, Corpora is able to effortlessly scale in terms of the size of your data set without sacrificing performance. In truth, the secret sauce of Corpora is precisely this sort of multi-model kind of database strategy. Another ingredient to the secret sauce of Corpora is the fact that it's built using Django. This allows the code base for Corpora to be inherently extensible. All these special tasks like indexing archives and performing URI attribution live inside a plugin folder that can be easily added to a given deployment without directly modifying the Corpora code base. And speaking of the extensibility of Django, one of the more popular features is the ability to leverage Jinja 2 templating when outputting data. So what you see here is the content type template editor, which allows you to create any number of templates for representing a particular content type. So in terms of presenting data to the public, you can create templates for rendering custom HTML, XML, JSON, or in this case, turtle statements that generate on-the-fly representations of your content, depending on your presentation needs. So here is a snippet of the same piece of content being represented up top using RDF XML, and here in the bottom, the turtle format appropriate for ingestion into the Lynx triple store. Either of those representations can be accessed by visiting the artifact's uniqueuri and just including the name of the template at the end of the URL. A shout out here to Aaron Canning, the Lynx ontologist, who did all the heavy lifting to create the turtle representation of ARC's metadata. As a final note, I wanted to mention that while we're fortunate enough here at Coder to have a rack of servers at our disposal to host Corpora at scale, Corpora's entire stack, including the 3 databases, the web app, the Nginx web server that orchestrates them, all of that lives inside of Docker containers. And as such, I do the majority of my development and testing with Corpora running on my laptop. So regardless of the kinds of computing resources a researcher has at their disposal, whether a single Windows desktop or a MacBook Air, Corpora can run on it, allowing them to build, improve, and wrangle their data sets without needing a sophisticated server infrastructure. Okay, that's all for now. Thank you so much.